Welcome back to the vlog. Actually, I've started a distribution of ocean and continent, which is the most important chapter for the optional geography. So I'm just revising it. I've already read it. I'm just revising it. It's about the continental drift. That it was Alfred Wegener, a German geologist, who put forth the comprehensive argument in the form of continental drift theory in 1912. And according to the Wegener, all the continents form a single continental mass, and the mega ocean surrounded the same. And this super continent was named Pangaea, which means all earth. The mega ocean was called Panthalasha, meaning all water. He argued about 200 million ago the supercontinent Pangaea began to split. Pangaea first broke into two large continental masses as Laurasia and Gondwana land, forming the northern and the southern components respectively. Subsequently, Laurasia and Gondwana land continued to break into various smaller continents that exist today. And उसके evidence में here it is written that matching of the continents, that is jigsaw fit rock of the same age across the ocean, and then tillite, that is carried of the deposits from one place to another, that is called tillite, and then placer deposits, and of course the distribution of fossils. The observation that lemurs occur in India, Madagascar and Africa led them to consider a contiguous landmass, Lemuria, linking these three landmasses. That is, Mesosaurus was a small reptile adapted to swallow blackish water. The skeletons of these are found only in two localities, the southern Cape province of South Africa and the Arabian Formation of Brazil. These all are just the example. And the next one is the force for drifting. That is, Wegener suggested that the moment responsible for the drifting of the continents was caused by the pole freeing force and tidal force. The polar freeing force relates to the rotation of the earth. The second force that was suggested by Wegener, the tidal force, is due to the attraction of the moon and the sun that develops tides in the oceanic water. Actually ये चैप्टर मैं पढ़ चुकी हूँ, that's why मैं ये जल्दी रिवाइज कर रही हूँ, because I have other subjects to do. So the next one is post-drift studies. That is, for the continent drift, most of the evidence was collected from the continent area in the form of distribution, flora and fauna, or deposits like tillite. Yes, that we know. Then conventional current theory, that is Arthur Holmes, 1930s, discussed the possibility of conventional current floating the mantle portion. These currents are generated due to the radioactive elements causing thermal differences in the mantle portion. And Holmes argued that there exists a system of such currents in the entire mantle portion, attempt to provide the explanation of force. Okay, ठीक है. Mapping of the ocean floor. Detailed research on ocean configuration reveals that the ocean floor is not just a vast plain, but it is full of relief. So, and then this is the ocean floor configuration. This is the mapping of the ocean floor. And yes, I have practiced this once. This is the mapping of the diagram भी साथ में practice करनी होती है guys. Then continental margins, so these are the transition between continental source and deep sea regions. The continental shelf, continental slope, continental rise, and deep oceanic trenches of this. The deep oceanic trenches are the areas which are of considerable interest so far as the distribution of ocean and continent is concerned. Then in next page we have the map. This is the shallow earthquake centers. The big one is the hot spot, ring of fire. The short one is volcanic eruptions. These are the volcanic eruptions. And we have the abyssal plains, then mid-oceanic ridges. What is the abyssal plains? These are the extensive plains that lie between the continental margin and mid-oceanic ridges. The abyssal plains are the areas where the continental sediments that move beyond the margin get deposited. So yes, we have, this is the different examples of the earlier earth, and the last one is plate tectonics. Yes, plate tectonics is also the example. This, we have talked about the Laurentian and Gondwana land, and this is the that we have to practice, because if the question asks from this type of the continental drift theory, we have to portray this one. So next one is plate tectonics. We all know the tectonic plate, also called the lithosphere plate, is a massive irregularly shaped slab solid rocks composed of both continental and oceanic lithosphere. And the Pacific plate is largely on the oceanic plate, whereas the Eurasian plate may be called a continental plate. Some important minor plates are Cocos plate, Nazca plate, Arabian plate, Philippine plate. Cocos, Nazca, Arabian, and Philippines. Okay. These are the Eurasian plate, African plates, North American plates, Southern plates. So, the next one, divergence boundary, where new crust is generated as plates pull away from each other. The sides are called the spreading side. The best known example of the divergence boundaries like Mid-Atlantic ridges from the Eurasian African plates. And divergence boundaries, then convergence boundaries between an oceanic and continental plate, between the two oceanic plates, and between the two continental plates. That is the convergence boundaries. Then we have transform boundaries, with the plates slides horizontally passes each other. That is transform boundaries. Rate of plate movement. Arctic rise slower rate, and the East Pacific rise near Easter Island is the South Pacific, about 3400 km west of Chile. And then we have force for the plate movement. Heat within the earth comes from two main sources, that is radioactive decay and residual heat. And Arthur Holmes first considered this idea in 1930. So yes. And then we have moment of the Indian plate. This one is important. So Himalayan from the northern plain boundaries in the form of continental convergence. In the east, it extends through Rocky Oma mountains of the Myanmar towards the island arc along the Java Trench, and reach in the southeast Pacific. The western margin follows the Keter mountain of the Pakistan, and it extends along the Makrana coast and joins the spreading side from the Red Sea Rift southeastward along the Kavuz archipelago. The boundary between the Indian and the Antarctic plate is also marked by the oceanic ridge divergence border running in roughly west direction and marching into the spreading side. And that's it. This much is necessary. बस इतनी सी हिम्मत करनी है, book खोलनी है, and then we have to start it, and then we have to finish it. And again we'll come back to this chapter after finishing the rest of the chapters. So thank you.